Welcome to AI Frontiers. Today's episode explores the intelligence revolution beyond scale, analyzing 125 papers from a single explosive day in machine learning research, December 17, 2025. This snapshot reveals a field transitioning from raw computational power to refined intelligence, with key themes of efficiency, reliability, and scientific fusion. Let's explore where AI is heading next. Why focus on a single day's research output? In the relentless churn of AI progress, trends crystallize rapidly. The papers posted on this Tuesday represent conversations, rebuttals, and leaps forward that speak to each other. This journey will explore four dominant themes emerging from these 125 papers, take a deep dive into three landmark studies that challenge fundamental assumptions, examine the methods driving today's breakthroughs, and look ahead to where this research trajectory is taking the field. The foundational category for this analysis is computer science, learning, often abbreviated as CS.LG. This represents the big tent of machine learning, encompassing everything from the pure mathematics of new optimization algorithms to applied AI systems that diagnose rare diseases by analyzing patient drawings. It addresses the fundamental how questions: how machines learn from data, how to make that process faster, cheaper, and more robust, and how to apply it to messy real-world problems. The field is transitioning from academic curiosity to infrastructural necessity, becoming the operating system for discovery across medicine, engineering, climate science, and social systems. The first dominant theme is the efficiency imperative, doing more with less in an age of constraints. The era of simply throwing more computing power at problems is hitting walls of cost, energy consumption, and latency. Researchers are responding with clever architectural designs. The tiny recursive control method demonstrates how microscopic networks can achieve sophisticated control through iterative thinking. The MEPIC system introduces new caching tricks that dramatically slash the memory requirements for serving large language models. This represents more than mere optimization, it's a fundamental reimagining of computational frugality as a core design principle. Theme 2 is algorithmic refinement and new paradigms, representing a move beyond standard playbooks. Instead of basic reinforcement learning from human feedback, researchers are exploring stackable learning from human feedback, framing preference alignment as a strategic game between AI and human. The posterior behavioral cloning approach ensures robot pretraining actually sets up successful reinforcement learning fine-tuning later. The field is increasingly dissecting its own recipes, asking not just does it work, but why does it work, and how can we make the recipe foolproof? Implementation details are being recognized as fundamental design levers. The third theme is the march toward robust and trustworthy AI. As systems leave laboratory environments, they must be engineered for dependability. This encompasses making AI resilient, fair, and even forgetful. Papers address machine unlearning, techniques to make models forget specific data without complete retraining. Others provide quantitative verification of fairness for automated decision trees and new methods for uncertainty quantification, enabling models to indicate when they're uncertain. Research also reveals how bias in historical data can entrench and amplify itself with alarming efficiency in classifiers, highlighting that trustworthy AI requires auditing data as much as inventing new algorithms. The fourth theme is convergence with scientific and physical domains. Here, AI transitions from mere pattern recognition to becoming a genuine partner in discovery. A pre-trained battery transformer acts as a foundation model for predicting battery lifespan. Neural networks emulate gravity-driven landslides to predict geohazard runout. Other systems solve complex physics equations in context, learning new differential operators on the fly. AI is being woven into the fabric of the scientific method itself, moving from purely data-driven approaches to theory-guided modeling. Several key findings from these papers have the potential to redirect the field's trajectory. Work on tiny recursive control demonstrates that for complex control tasks, capacity can emerge from iterative reasoning depth, not from parameter count. A federated learning project for diagnosing collagen V-related dystrophies proved such collaborative frameworks can shatter data scarcity barriers in critical healthcare. Research on exploration versus exploitation revealed that so-called spurious rewards improve reasoning through a specific mechanical effect, clipping bias. The posterior behavioral cloning paper showed standard behavioral cloning creates a poor foundation for reinforcement learning. Finally, studies confirm that bias in historical data entrenches itself with alarming efficiency. The methodological engines driving these breakthroughs are as innovative as the results. Attention-based sparsification and optimization addresses the quadratic cost of standard attention. Methods like Cascade achieve 4x speedups in generation through training free sparse attention. Sharpness-aware minimization is being applied to non-ideal scenarios like federated graph learning, optimizing for smooth error curves. Geometric and topological representations transform non-Euclidean data into structured mathematical spaces algorithms can grasp. Underpinning much applied work is the continued evolution of reinforcement learning fine-tuning, with pipelines being rebuilt from first principles to create policies explicitly pre-adaptive to fine-tuning. The first selected paper is Exploration vs Exploitation, Rethinking RLVR through Clipping, Entropy, and Spurious Reward by Peter Chen and colleagues from 2025. This work cracks a puzzling paradox in aligning large language models with reinforcement learning with verifiable rewards. The puzzle was that both using spurious rewards and directly minimizing policy entropy, seemingly opposite strategies, improved reasoning. Through meticulous ablation studies and measurement of policy entropy, the team discovered the benefit wasn't in the spurious signal itself, but in a side effect. The common practice of clipping rewards created a clipping bias that flattened the reward landscape, which during optimization systematically reduced the entropy of the model's output policy, leading to more confident and correct answers. This moves alignment from alchemy to applied science. The second landmark paper is Posterior Behavioral Cloning, Pretraining BC Policies for Efficient RL Fine-Tuning by Andrew Wagenmaker and colleagues. This research asks a deceptively simple question that upends standard practice: is the way robots are typically pre-trained actually optimal for subsequent reinforcement learning fine-tuning? The authors hypothesized standard behavioral cloning is a flawed foundation because it can fail to provide adequate coverage of the expert state-action space. Their solution, posterior behavioral cloning, trains the policy to model the entire posterior distribution of the expert's behavior given all demonstration data. When tested on robotic manipulation benchmarks, policies pre-trained with post-BC consistently achieve superior final performance after RL fine-tuning. This reframes the goal of pre-training from imitate to prepare a robust search space. The third paper is Tiny Recursive Control, Iterative Reasoning for Efficient Optimal Control by Amit Jain and colleagues. This work presents minimalist genius for hard-constrained environments like drones or spacecraft where power, memory, and latency are severely limited. The Tiny Recursive Control method uses a remarkably small neural network, approximately 1.5 million parameters, run in a recursive loop with a two-level hierarchical latent structure. In each iteration, it simulates trajectories, evaluates tracking error, and refines the control sequence. The key insight is that capacity emerges from iterative depth. The same tiny set of weights is reused. This tiny controller achieved near-optimal performance on tough nonlinear control problems using mere milliseconds on a GPU and under 10 megabytes of memory, successfully applying chain-of-thought reasoning to the physical world. Future directions indicated by this research include deeper fusion with domain knowledge and physical laws, moving toward theory-guided models that inherently respect conservation laws. Collaborative, privacy-preserving frameworks like federated learning will become standard across sensitive domains. There will be increased co-design of algorithms, hardware, and systems, with efficiency techniques integrated from the ground up. The vision points toward generalist, in-context learning systems capable of open-ended discovery. Concurrent challenges that must be addressed include reproducibility, developing ethical and governance frameworks, and managing unforeseen vulnerabilities introduced by new capabilities like machine learning. This presentation was synthesized using advanced AI systems. Content synthesis was performed using the GPT DeepSeek chat model. Text-to-speech synthesis was accomplished via Amazon Polly. Image generation utilized Stable Diffusion technology. The entire process underwent human expert review for accuracy and coherence. A caveat is noted: while thoroughly reviewed, some oversights may still exist in the synthesized content. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from the arXiv preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: This video uses arXiv preprint server content under its API terms of use. AI Frontiers is not affiliated with or endorsed by the arXiv preprint server.